Have you ever tried carrying out two activities at the same time? You discover that there are certain activities you can do together. There are some you cannot do together. If you tried cooking and washing the dish, it is possible to carry out those two activities together. Today we'll be looking at simultaneous linear equation. It's an equation that enables us to solve two linear equations together that could not be solved independently. If two equations involving x and y variables are both satisfied by one or more pairs of value x, y, we say they are simultaneous equations. There are two methods we'll be looking at in solving simultaneous equation. Now, these two methods are elimination method and the substitution method. To enable us understand how these two methods are being used, we are going to use an example to illustrate it. The first example we will be looking at is solving 2x plus 5y equal 1, which we'll call our equation 1, and 3x minus 2y equal 30, which we'll call equation 2. To enable us to solve this equation, we are going to eliminate one of the variables, either x or y. The process of doing that, we'll use one of the variables to multiply one of the equations. Let us try to eliminate the variable x. So we are going to use the coefficient of x in multiplying one of the equations. Let us multiply equation 1 by the coefficient of x in equation 2. So 3 times 2 will give us 6x plus 3 times 5 will give us 15y equal to 3 times 1 will give us 3. This has given us a new equation which we will call equation 3. And if we do the same thing in the reverse form, using the coefficient of x in equation 1 to multiply equation 2, we'll say equation 2 times the coefficient of x in equation 1. 2 times 3x will give us 6x. 3 times minus 2 will give us minus 4y to be equal to 2 times 30 will give us 60. And we'll call this equation 4. Now, if in equation 3 from equation 4, we'll have 6 minus 6, x must have been eliminated. So we have 15 minus this, we're going to have 19y equal to minus 57. So dividing through by 19, we're going to have y to be equal to minus 3. Now, we are going to substitute the value of y equal minus 3 into equation 1. Of course, we could substitute that into equation 2, whichever one, but we are going to do that into equation 1 right now to get the value of x. So doing that, we have 2x plus 5 into minus 3 equal to 1. So this gives us 2x minus 15 equal to 1. And taking minus 15 over, we are going to have 2x to be equal to 16. Dividing through by 2, x will be equal to 8. So when we have x equal to 8 and y equal to minus 3, this becomes the pair of values that satisfy these two equations. We have been able to solve these equations simultaneously. We can actually check if our answers we got is correct by substituting these values into equation 1 and equation 2. To do that, we are going to have, from equation 1, we are going to have 2 into x. We have x, the value of x as 8, so we have 2 into 8 plus 5 into minus 3. Now, 2 times 8 is going to give us 16. 5 times minus 3 will give us minus 15. And of course, 16 minus 15 is going to give us 1, which is actually the value in equation 1. And if we do the same thing to equation 2, we will have 30. 3 into 8 minus 2 into minus 3. 3 times 8 will give us 24. And minus times minus will give us plus. 2 times 3 will give us 6. 24 plus 6 is equal to 30. Hence, our answer that we got is correct. As a follow-up to the class, this is an assignment to show your understanding. Solve the following pairs of simultaneous equations. Number 1, 4a equal 1 minus 3b, 4b equal minus 1 minus 6a. And question number 2, 5x minus 19 equal 2y, and 3y plus 18 equal 4x.